In the previous video, you guys saw how to do matrix multiplication, correct? How do we take the rows and columns and how do we multiply? That multiplication part is done. Now let's try to understand few properties of multiplication. Fair enough? Now the first very important property is that the commutative law. Now matrix multiplication is not commutative. In the sense, in the commutative part, so in the commutative law, AB is not equal to BA. Now we can start off with two reasons why this is not possible. Okay, now one of them is the order of the matrix. Like in the sense, suppose if I take 2 cross 1, okay, 2 cross 1 and 1 cross 3, if I take it, now AB is possible because 1 and 1, this is possible, but BA is not even possible. Correct? This is one way of how we can express that this is not possible. The second way is, even if you take the same order, in the sense, let's say you take 2 cross 2 matrix and 2 cross 2 matrix. By order wise, they are okay, like they satisfy the condition. But number wise, they won't be the same. Okay? In further videos, you guys will see few example problems. Then you will understand why it is not true. Okay, so this is one first property of matrix multiplication. The second one is associative law. Now, matrix multiplication do obey associative law. In the sense, AB multiplied by C is equal to A into multiplied by BC. This holds good. So, matrix multiplication is closed under associative law. Okay, the third one is the identity, presence of an identity element. Okay, now this one, in the sense, suppose you have A as was some matrix, A into I is equal to I into A is equal to A. Okay, identity element, again, it depends on what type of matrix you are taking. In the sense, are you taking a third order square matrix, fourth order, second order square matrix? Based on that, we are going to multiply with the identity element. Alright. The next identity or the next property what you have is the inverse. In inverse, what you have is that, suppose say you have a matrix A, then we multiply with the inverse of a matrix, what we call as A inverse. So A into A inverse is equal to A inverse into A is equal to identity element I. Okay. Now presence of inverse of a particular matrix. Now there is one more property. That is, what if you multiply a matrix with some scalar quantity? In the sense, scalar multiplication. This is the next one. Okay, scalar multiplication. In the sense, suppose say you have matrix A, some matrix A. Okay, let's take an example and do it. Let's say this is 3, 1, 2, 5. Now say I multiply this matrix with a scalar quantity of, let's say, 3. So that means if you do 3A, this becomes 3 into each and every element of the matrix. So 3 into 3 is 9, then 3, 6, 15. In the sense, when you multiply lambda into A, then each and every element of the matrix gets multiplied by the constant. So lambda into A is equal to lambda into Aij of M cross N. Each and every element should be multiplied. Okay, now these are certain properties of multiplication of matrices. In the sense, you can multiply a scalar with a matrix, or you have multiplication of matrices where a very important point is the number of columns in the first matrix should be equal to number of rows in the second matrix. Correct? This is a very important point. Then you have commutative, associative, identity, all those properties. Fair enough? From the next video, we'll see more number of problems based on whatever you have learned so far, based on addition, subtraction, multiplication. Okay, from the next video onwards, we will see more and more number of problems.